Okay, so letter D is a hot mess. There is all kinds of craziness going on. So when that's the case, again, you've got to be looking for a substitution of some sort. One thing I know is I'm not going to do anything with the 16x cubed because that's a smaller power than what's inside here. The other thing is I'm looking for something maybe that's under or inside of another function, like the square root is a function, the natural log of that is inside of it. And you may have to do a little bit of trial and error, but if I let u equal the thing under the radical, so natural log of 3x to the fourth plus 5, and then do a du dx, or take the derivative of natural log of that thing, it's going to be 1 over that thing, which is good because I've got that thing under, in a denominator here, times the derivative of the inside of the natural log, so 12x cubed, and then the derivative of 5 is 0. So this is du equals 12x cubed over 3x to the fourth plus 5 dx. I just multiply both sides by dx. So now I start looking at what do I have and how's this going to help me out. So I have a dx, and I have a dx. I have this in a denominator, which is what I want. And I also have the x cubed. I just don't need the 12. So I'm going to multiply both sides by 1/12, or divide by 12 to cancel that out. So now I can do some serious simplifying here. The 16 can come out in front. This square root of this natural log thing is just u. And then the x cubed over 3x to the fourth plus 5 dx is right here. X cubed over 3x4 plus 5 dx. So that's the same as du over 12. The 12 can come out, but it's in a denominator, so it's 16/12 integral u to the 1/2 power, because again, calculus likes powers, not radicals. And then go ahead and integrate u to the 1/2. So you add 1 and then divide by whatever that is, or flip it around, however you think of that. So 16/12 times u to the 3/2 divided by 3/2, or times it by 2/3. So 16/12 times 2 over 3, keep change flip, u to the 3/2, and then plus a c, but then take out your u and put in that natural log thing. So this can all be simplified down. 16/12 is 4/3 times 2/3, and the natural log of 3x to the fourth plus 5 plus c, and then go ahead and multiply those two things together. But you're looking for, like, when you do this u substitution, you're either looking for something with a bigger power or something under or inside of a function. So under a radical is a good place to find a u substitution thing, or sometimes in a denominator, sometimes not, but it's just, you got to kind of keep your eyes open for it. Now this guy, even though it's under a radical, there was no like x power. So like if I took the derivative of 1 minus x squared, it would be a negative 2x, and there's no 2x to cancel that out. So I know that, like up here, these two guys were some special inverse trig functions that I would be looking for, and not a substitution. All right. So on problem 8, this one's just straight up integrated and then substitute in your values. Letter C, since there's only one term in the denominator, I would split this up. And you can do this because there's just one term in the denominator. Integrate from 1 to 2 dx. And then simplify. So integral from 1 to 2 of 5x minus integral from 1 to 2. 1 over x squared, again, move those up to a numerator, and then it makes it easier to use your, like power rule thing on it. Add 1 and divide by. Okay, and then integrate each of those, and then evaluate from 1 to 2. These next two look a lot like something that needs to have a substitution going on. So again, if I were a guessing person and not looking at the answer, I'm looking at this function here is inside of a square. So that's probably what I would let u equal. Not the square though, just that, what's inside. Then take the derivative of that. Derivative of 7 is gone, so it's 2. Derivative of cosine is minus sine x dx, which is kind of cool because I have a sine x dx here, and if I let this get substituted out, I can pull the 6 out in front. I'm going to divide here by -2 so that I've got the du over -2 is sine x dx. So du over -2. And then on the bottom here is also u squared. All right, I'm going to drop the limits off until I switch it back to x's. So 6 over -2. And then pull the u to the 2 up, integrate that, so again add 1, divide, oops, drop the integral symbol off, so u to the -1 divided by -1. Where were they going with this? So that's going to be 3 u to the -1. And then change the u back to what u was. So 3 times 7 plus 2 cosine x. And then once we're back to x's, I can use those limits of integration. Pi over 3 to pi. And that's where you're going to have to remember your trig and substitute in and simplify. Okay. For this guy, again, look for something under a radical that's kind of big and clunky, and it's got a bigger power than what's on the outside. So if I let u equal that big clunky thing inside, 7x squared plus 12x plus 8, then du, take the derivative, 14x plus 12 dx, which is pretty cool because you got the 14x plus 12 dx here. So I don't have to do any dividing or anything because that's directly substituting in the du for that mess there. So this becomes the integral of, drop your numbers off, don't worry about those right now, the cube root of u, and then another name for this 14x plus 12 dx is du. Change it to a fraction exponent because again you can't do anything with the radical, and then go ahead and integrate. So integrate, switch out your u for the 7x squared plus 12x after you integrate. So if I integrate this, this is going to be u to the add 1, which would be 4/3 times 3/4 switch out the u after you integrate x squared plus 12x plus 8, and then evaluate from 0 to 1. And then plug it in and bring it on out.